Now, in the last few weeks, I've made quite some videos about retrieval augmented generation, or RAG. Now, in today's video, I'm going to take this one step further, because today we're going to build an agentic RAG with Python and LangChain, which you can use with your own documents. Some of you have also asked me whether we could use Supabase in one of my next videos, and I've listened to you, and we will be using Supabase as a vector database in this video. Now, before we open VS Code and start building our own agentic RAG, I want to take a few moments to explain to you why agentic RAG is so much more powerful than naive RAG. So what you see here is the working of what we call naive RAG. So this is how retrieval augmented generation normally works. So the user asks a question, for example, what's the color of a banana? Then based on this question, a similarity search is executed on a semantic database. So this means that we're going to try to find text in a semantic database, which is semantically similar as the question of the user. So we're going to get all the texts that have something to do with color or banana, and preferably both. And then we take the one or multiple results, we provide them to a large language model together with the initial question from the user, and then the large language model is going to answer the question from the user based on the chunks that we provided. And if you've watched some of my previous videos, you probably know that this is one of the easiest ways to use large language models based on your own data. But naive RAG is far from ideal, and let me show you why. So what you see here is the website from LangChain, and in this example they show why agentic RAG is so much better than naive RAG. So you see that the human asks the question, for example, what is task decomposition? And then the AI provides the answer, and then you will see that the human asks, what are common ways of doing it? And you probably know that if you use frameworks like LangChain, you can always provide the entire conversation that you're having with the large language model to the large language model, so it always knows the history. So we're only providing the last question to the semantic database. So in this case, the semantic database only gets the question, what are common ways of doing it? And it doesn't understand that we are still talking about task decomposition. So it's probably going to provide us documents that have something to do with common ways or with doing it, but nothing related to task decomposition. So what you see here is the architectural design of an agentic RAG. So you see that central to the agentic RAG, there is a large language model, and then this large language model has access to memory, it can do some planning, and it has access to tools. For example, it can do vector search, it can do web search, and it has access to some APIs. And because it's an agent, it can decide itself when to execute these tools, and that's really important. So let's imagine that we provide the same question that we just provided to the naive RAG, but this time to the agentic RAG. Now the agentic RAG can now decide whether it wants to execute a tool call, yes or no, but it can also reformulate the question based on the entire history of this conversation. So by knowing the entire history of a conversation, it can now reformulate the question, and it can ask, how does task composition actually work? Now this question will again be routed to a semantic database, but in this example, it gets back documents that are actually relevant. Now another fundamental difference between naive RAG and agentic RAG is that agentic RAG can actually choose whether it wants to execute a tool call. So if you just ask the chatbot, how are you? The agentic RAG can choose not to make a tool call, and it can just respond with saying something like, I'm a chatbot, I don't have feelings, blah, blah, blah. And you can imagine that this can improve the performance of the chatbot. Now this image shows the development from naive RAG to advanced RAG, modular RAG, graph RAG to agentic RAG, where agentic RAG is definitely the most sophisticated version of RAG that we are using nowadays. And then it's time to dive into the scripts. So I have three scripts here. I have the script that I use in order to ingest the document into the semantic database. Then there is a script to test the agentic RAG. That's this one. It's a relatively small script. And then I have as well this script, agentic RAG with Streamlit, where we're going to integrate the agentic RAG into a Streamlit chat application so that we can chat with our agent from this nice chat interface. Now, before I'm going to walk you through the script, let's take a look at the document that we will be using today. So this is the document that we're going to load into the semantic database, and then we can ask questions about this document to our agentic RAG. You see that it's a paper, and this paper explains about the differences between naive RAG, other RAG systems, and what we will be using today, agentic RAG. Now you can find all the scripts that we will be using today back on my GitHub repository, and you can find the link to this GitHub repository in the description of this video. Now, in my previous videos, many of you have asked me to use a Supabase database, so that's what we will be using today. So just create an account on supabase.com. That's entirely free. And if you have created that account, we're going to start with creating a new project. So just click here on new project. We have to give a project a name, so I'm just going to call it project, and we have to give it a password as well. And then you can select here your region. I'm going to go for Germany because I'm located in Europe, and then click here on create new project. Now in my GitHub repository, you'll find a file that is called .env.example. That's this one. Just rename it to .env, and then you'll get this file. Now you're gonna need an OpenAI API key. I've already filled in my OpenAI API key. If you don't know how to get it, there is another video on my channel that explains the entire process. And then we're gonna fill in here our Supabase URL and our Supabase service key. And let me show you where you can find those. So this is the project URL. So I'm just going to copy this one, paste it right here. And then we're going to copy our API key and we're going to paste that right here in our Supabase service key like this. And as soon as you've done this, just save your .env file. And there is one more thing that we need to do in order to get our Supabase database working. So by default, Supabase is a normal Postgres database. So in order to make it a semantic database, we have to make some changes. So navigate to my GitHub repository. And on my GitHub repository, you'll find here this SQL query. It's exactly the same SQL query as you will find as well on the LangChain website. So we're just going to copy this. Now navigate back to Supabase. And then we're going to open our SQL editor. And here we're going to just paste this. And then we're going to run our code. Now, before I'm going to execute this piece of code, I want to explain something. So you see here the number 1536, and you see it here as well. And this is related to the amount of dimensions of the embeddings model. So if I navigate here to this website, then you will see here that OpenAI has different embedding models. If you don't want to use the OpenAI model, by the way, you can also use a local embedding model, for example, one running on Olama. But I'm not going to explain that in this video, and maybe I will create another video about that. But here you will see the different embedding models that OpenAI is offering. And you see here, for example, we are using, let me just double check. We are using text embedding 3 small, this model. I will see here that this model, text embedding 3 small, has 1536 dimensions. And as well, the text embedding ADA002 model has also 1536 dimensions. But for example, the text embedding 3 large has more dimensions. So you can use those two models, but you cannot use this one. And otherwise you have to make some changes to your code. You can as well use this model to generate a lower number of dimensions, for example, 1536, but that's a bit more complex, and maybe I'm going to explain that in another video. Then you see here as well that all the models have a max number of tokens of about 8,200. That's as well important to keep in mind. And it's good to know that we are generating chunks here of about 1,000 characters, which should be less than the 8,200 tokens that this embedding model can handle. Okay, now before I forget, let's execute a SQL query to turn this database into a semantic database. So let's run it. And then you should see something like this: success, no rows returned. And this means that our table has now been created in order to save our vector. So let's navigate to the table editor, and then you should see here documents. And then you see here that we have created a table with every document is going to get an ID. It's going to have content, it's going to have metadata, and it's going to have all the embedding vectors, which are going to be stored here. Now let's navigate back to the script, and before I'm going to execute it, make sure that you have saved your .env file. That's really important, otherwise you're going to get a big fat error. So save it, then navigate to ingest in db.py, and then let's run the ingesting script. You'll see that I'm importing the libraries here. I initiate the Supabase database based on the information in the .env file. We initiate the embedding model, and then we're going to load all the documents in the folder documents. Now, of course, you can use the same paper as the paper that I'm providing here in the documents folder, but you can as well provide other PDF documents to this folder if you want to ask your Agentic RAG questions about those documents. And basically, this ingestion script will add any document that you provide into the documents folder to the semantic database. Then you see here that we are splitting the PDF document in small chunks. So you see that the chunk size that I've chosen here is 1,000 characters, which is a bit more than in previous examples if you've watched some of my other videos. And that's because this document is a scientific paper, and I found out that if I make smaller chunks, or for example 300 or 400 characters, it doesn't get all the context that it needs in order to answer the questions. So if you work with semantically less complex documents, maybe a Wikipedia page or something, I would set the chunk size a bit lower. But for this scientific paper, which is quite complex and has quite some semantic complexity, I would definitely set the chunk size a bit higher. And then you will see here that we create the vector store. So we add all the documents here to the vector store. So let's run the script. Okay, let's now take a look at the database. So we can just refresh this page. And then you see here all the chunks that we have added to the semantic database. So you see that every chunk has its own unique identifier. We can use these unique identifiers in order to update or delete the chunk. Then you see here the content. You can click on it if you want to see the entire content. And then you see here the metadata. So we have as well information about the document. So you see that we have a lot of metadata here about this chunk. We have the page on which this chunk appeared. We should have the title, the author, etc. But we have the name of the PDF document, etc., etc. And we can use all this information to ask our Agentic RAG for sources. So if that's something that you want, you can add that to the prompt as well. And I see here the vector embeddings. Now, before continuing with showing you how you can build the agent that is going to answer questions based on this semantic database, there's something else that I want to show you. Many times a day, just like yourself, I stumble on Python scripts that I want to try out. And rather than copying this snippet to VS Code, creating a virtual machine, etc., etc., there is now a new Chrome extension. And with this Chrome extension, I can just click here on Run Python, and this will actually execute the script right in my browser. Now, the name of this Chrome extension is ClipRun. And if you navigate to cliprun.com, you can download this Chrome extension entirely for free, no strings attached. Okay, so let's take a look at the agent, and let's start with a very simple example. So you see that I'm including all kinds of libraries here. Again, I'm initiating the Supabase database, and I'm initiating the embeddings model and the vector store because we're also going to need them for the agent. Now you see that I'm initiating the large language model right here. So in this case, I've chosen to work with OpenAI, and you see that I've set the temperature to 0 because I don't want the model to be like creative here. I just want it to stay with the facts. Then here we pull a prompt from the LangChain / LangSmith prompt library, and that's exactly this prompt. So it just says you are a helpful assistant, and it provides some space for chat history, and it also has an agent scratchpad where the agent can then leave notes. And of course, we as human, we can provide input. So later I will show you how we can work with this template. But first I want to show you the retrieval tool. So this entire function here is the retrieval tool. The input is a query, and this is the query that the agent is going to create based on the question from the user. And then with this decorator here, we mentioned that this is a tool. So this is how we showed LangChain that this function is a tool that it can be used by the agent. And we also provide here the response format, which is content and artifact. Then we provide a description of the tool here, retrieve information related to a query. We do a similarity search. We always want 2 results, but if you want, you can as well change this to 5 or whatever you prefer. And then we serialize here the documents and the metadata, and we provide them back to the agent. Now this is important because here we're going to define all the tools that the agent has access to. So this is retrieve the function that we have just seen. Of course, if you want, you can add more functions if you want to provide more tools to the agent. And then this is where we're actually going to create the agent. So create tool calling agent, and we create this agent based on the large language model that we have defined here, the tools that it has access to, and the prompt. So this is all you need in order to create an agent. You need a large language model, you need tools, and you need a prompt, of course. And then we create the agent executor here. And the agent executor is some kind of like an executable that we can just execute whenever we need the agent. So we are creating the agent executor here. We are referring to the agent that we have created earlier. We provided tools, etc., etc. And then this is where we are going to invoke the agent. So just like with other uses of LangChain, you just have to invoke this agent, and normally you will invoke it multiple times. So every time the user asks a new question in the chat, we're going to execute this this agent executor, and of course we're going to update the information here. So I will show you that in the next section, but first you see here that we are providing inputs to the agent when we invoke it. Why is Agentic RAG better than naive RAG? So let's see what the agent is going to find in the database. And once we execute the agent, you will see that this is the initial question. Why is Agentic RAG better than naive RAG? But to the database, the agent is sending the following query, Agentic RAG versus naive RAG, because of course with this query, it's way easier to find information in the database that is semantically related than with this query. So the agent has already optimized this query for us. And then if you scroll down, you will see the answers that the agent is getting back from the database. So you will see here first source, that this is all the metadata. And then you will see here, this is where the content is starting, processing, unlike traditional RAG, Agentic RAG employs autonomous agents, blah, blah, blah. So this is the first chunk that it's getting back. And now you as well see why it's so important to provide larger chunks to this Agentic RAG. And that's just because this topic is so complex. So if we would upload, for example, a book for children who are 12 years old, we could as well work with chunks of 200 or 300 characters, because the content is semantically less complex. And then you will see here the second chunk that we are retrieving. You will see the metadata, and then here as well the content, resulting in Agentic RAG, blah, 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 blah. And the answer that we are getting based on those chunks, so then the agent is going to create the answer based on the chunks that it has received, is Agentic RAG is considered better than naive RAG because Agentic RAG employs autonomous agents. And if you search for this query, you will see that it's using the exact words that are used in the chunks that it has received from the database. So I hope this example already shows you why Agentic RAG is so much better than naive RAG, but I'm also going to show you a second example where we have a larger conversation with the Agentic RAG. So the script that I'm using here is Agentic RAG streamlit.py. So this is all the same. It's all the same as in the previous example. It's the same tool that we are providing to the agent. But where this script is really different is here, because we're also going to integrate the Agentic RAG here with Streamlit so we can have larger conversations. So if you want to learn more about this piece of code, I have another video on my channel that explains how you can integrate LangChain with Streamlit. But for now, it's enough to know that we are keeping track of all the messages that we are sending to the large language model and all the messages that the large language model is sending back to us. So you see, in this case, we always start with the user asking a question to the Agentic RAG. And then as soon as the user has sent the question, we're going to save it in Streamlit, and we're going to then invoke our agent. And as soon as we are invoking our agent, this is really the most important line in this piece of code. As soon as we invoke the agent executor, we are sending the user question, of course, to the LLM, but we are as well sending the entire history, so the entire chain of all the messages to the large language model. And I'm going to just show you why this is so important. So let's run this piece of code. Let's open a new terminal and then type Streamlit, run, and then the name of the Python script. Okay, so the first question I'm going to ask is, what is Agentic RAG? Then we're getting back this entire paragraph, and this is of course based on the information that the Agentic RAG is getting from the database. So here you see all the chunks coming from the database, and then you see here the answer that the LLM is creating based on those chunks. And now let's try exactly the example that we have earlier seen on the LangChain website, which shows us why sometimes a naive RAG really doesn't perform very well. So let's just ask. And you know, of course, that it is referring to Agentic RAG, but of course, if you don't have the context of this entire conversation, you don't know this. So this is why Agentic RAG is going to perform way better than naive RAG in this case, because it's going to rephrase the question and then send it to the semantic database. So let's see how this works. So this is the question that we have sent to the LLM. So let's see what the agent is going to make out of this. And now you will see that the agent has chosen not to send a query to the semantic database. And that is because it is using the answers from the chunks it has received earlier from the semantic database to answer this question. Now, I really hope this video was useful for you. If it was, please don't forget to give it a thumbs up. And I really hope to see you back in my next video, where we're going to build an AI agent which is going to execute real actions which have an impact on the outside world. I hope to see you there.